Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and in this video we are going to graphically derive the equations of motion in one dimension. Basically, we only talk about 3 equations of motion, but there are 2 more which are additionally going to help you in solving the numericals. But remember that these equations of motion, they only hold true for a straight line. That means motion in a straight line. Point number 2. Whenever the acceleration is constant, then and only then these all equations will hold true. If the acceleration keeps on changing with time, then you can't apply these equations. Okay, let's start. So we have here a velocity versus time graph, and at time is equal to 0, this velocity is known as initial velocity u. So here the time is 0, time is an independent quantity, it has to be plotted over x-axis represented by small t. Now, corresponding to, say, time t, this is time is equal to t, this is time is equal to 0, we have the velocity as v, final velocity. So at time is equal to 0, we have initial velocity u, at time is equal to t, we have final velocity v. Now this graph is so taken such that the acceleration is constant, because all these equations will hold true if the motion is in one dimension as well as acceleration is constant. So if you take velocity versus time graph, a curved one, over there the acceleration will change with time and these equations will not hold true. Alright, now the first thing that I'm going to do is to find the slope, right? We are going to derive the first equation of motion. Slope is basically change in y-axis by change in x-axis. So to find the slope, we require 2 points. So one is this point and the another is this point. We do know the coordinates, x-axis first. So this is t, y-axis then after. So t and v are the coordinates, and for this particular one, the x coordinate is 0, y coordinate is u. So since you know the coordinates, you can find out the slope. This can also be written as y2 minus y1 upon x2 minus x1. So this is how we can find the slope, by using 2 points. Now you can consider any point as point number 1 and any point as point number 2. So I'm going to call this as x2 y2 and this is x1 y1, right? So now let's substitute the value and find out the value of slope. So y2 is v minus y1 is u divided by x2 is t minus x1 is 0. So this is v minus u by t. Now slope is basically y-axis change divided by x-axis change. So y-axis quantity divided by x-axis quantity. So velocity divided by time. So basically this is change in velocity divided by time. So we get acceleration. So the slope of the y velocity versus time graph gives us the acceleration. So just cross multiplying, you can even rearrange v is equal to u plus at. This is our first equation of motion, correct, that we have derived from this graph. Alright, now in the second part, what am I going to do is, I'm going to find the area. So area is always under the graph, right? So this is our graph. So basically this is the shaded part, area below our graph and above x-axis. So this part, shaded area, is what I am interested in. And what will I get after finding the area? Area is basically y-axis quantity multiplied by the x-axis quantity. So velocity multiplied by time. So I will get the displacement. And displacement is going to be represented by s, right? So we can do it in one shot, right? What we can do is we can identify this trapezium and we can directly write the area of the trapezium. But instead, you can also divide this entire trapezium into 2 parts, one triangle and the another rectangle, right? So first of all, let's find the area of the rectangle. Now this gap is basically u minus 0. So this length is measured over y-axis, that is u. Now this length is t minus 0. So this whole length from here to here is t, correct? So the area of this particular rectangular part is u times t, because length times breadth is our area. Okay. Now, how would I find the area of the triangle? Triangle is half multiplied by base. So base length is same as t minus 0. So this entire length from here to here is t, multiplied by the height of the triangle, that is from here to here. Now see, from here to here the whole length is v. You can see that this whole length is v minus 0. So this whole length is v, this part is u. So this gap or the height of the triangle is basically v minus u, because this is v, this is u, this is v minus u. So this is v minus u times t. This is the area of the triangle. This is the area of the rectangle. So the total area under the graph is the sum of these two. All right. Now, basically this would give me the displacement. So displacement is equal to ut plus, I should be saying this as half times t. I will substitute v minus u as v minus u is equal to at, because if you cross multiply you will get the value of v minus u as at. So I'm going to substitute here as at. So finally I'm going to get the equation as s is equal to ut plus half at square is my second equation of motion. S is the displacement, u initial velocity, t is the time taken, a acceleration, again t is the time taken. Now, what could be done here is, I would be opening up this bracket. So what will I get? S is equal to ut plus half vt minus of half ut. Now ut minus of half ut is plus half of ut. So S is equal to half of ut, this minus this is this, plus half of vt, which means S is equal to half common, t common. I can also say u plus v, or I can also write this as u or v plus u by 2 times t. This is my equation number 3. Displacement is, I should be writing over here, displacement is u plus v by 2 times t. I call this equation as the Brahmastra. When all other equations fail to give the value, this equation will always solve your problem. Now, if you look carefully, this is displacement is velocity into time. And I'm going to call this as V average. This is average velocity times time. Correct? Why I'm saying this? Because displacement is average velocity into time. This equation is only true if acceleration is constant. If acceleration keeps on varying, then u plus v divided by 2 is not the average velocity. Again, I'm saying if acceleration is constant, then and only then average velocity is equal to v plus u by 2. You can only use this if acceleration is constant. Now in the fourth equation of motion, I'm going to again take S is equal to u plus v by 2 times the t. This was the last equation which we derived. Now this is what our average velocity is. Now we also know that v minus u is equal to at, right? So from here I'm going to find out the value of time. So that is equal to v minus u by a, and I'm going to substitute it over here. So displacement is v plus u by 2 times, this is the value of time that I'm going to substitute. This is v minus u by a. Now we know the identity in maths that a plus b, a minus b is a square minus b square. So here this is a plus b, a minus b. So this is a square minus b square divided by twice of a. Okay. Now if I cross multiply, I get the value as v square minus u square is equal to 2as. This is the fourth equation that I said. So the last equation which is remaining is the distance traveled by the body in nth second. So the first equation was v minus u is equal to at. The second equation was s is equal to ut plus half at square. The third equation, s is equal to u plus v by 2, where this part is the v average times t, and the fourth equation is of course this one. Okay, now let's talk about the last equation Now over here, this is the car at say time t is equal to 0, initial velocity u. Now this car is accelerating. So with respect to time, the velocity increases. Say for example, at 4th second, the car was here. At 4th second, right? Now I'm saying the car continues to move in a straight line, and say for example, the car reaches over here at time is equal to 5th second, and in the same way the car reaches over here at time is equal to 6th seconds. So at 6th second the car is found to be here. So this is the initial starting point, right? And say for example the car travels a total distance of s meters from here to here. Okay, so in 6 seconds the car travels this much of the distance or displacement, because all of them, they mean the same in a straight line. All right, our main purpose is to find out the distance traveled by the car in 6th second. So what you do is from time 0 to time 6 seconds, this is the total distance traveled by the car in 6 seconds, and then minus 1, time minus 1, so 5 seconds. From 0 to 5 seconds, this is the distance traveled by the car in 5 seconds. So this is distance traveled by the car in 6 seconds, this is distance traveled by the car in 5 seconds, and this gap is said to be distance traveled by the car in 6th second, th. Distance traveled by the car in 6th second is distance traveled by the car in 6 seconds minus distance traveled by the car in 5 seconds. Now in the same way, if I generalize distance traveled or the displacement traveled by the car in nth second, that is equal to distance traveled by the car in n seconds minus distance traveled by the car in n minus 1 seconds. Correct. Now this n is basically the time, so s is equal to u, the initial velocity is u, now ut, now here the time is n, plus half, during this entire motion acceleration remains constant, half a n square. This is the distance traveled by the body in n seconds minus distance traveled by the body in n minus 1 second. So what should I write down? U n minus 1, instead of t, substitute n minus 1, plus half a n minus 1 the whole square. Correct. Now let's open up the bracket, and this is un plus half a n square minus, let's open up this bracket, un minus u plus half a square minus 2ab plus b square. Open up the bracket once again, so we get un plus half a n square, this is minus un plus u, okay, I'm going to go very slow, minus half a n square minus 2n plus 1, that is un plus half a n square minus un plus u minus half this is half a n square minus minus plus 2 to cut, so it is plus a n minus half a. Okay, now what gets cancelled over here is un minus un, half a n square minus half a n square, so what is remaining is the following, this is u, then a n, that is plus a n minus half a, so it can be written as u plus, I'm going to take half common, so I'm going to multiply up and down by 2 and 2, and a common, so half a comes outside, so here it is 2n minus half a comes out, 1 is the answer. So the distance traveled by the body in nth second is given by u plus half a 2n minus 1. Just now you saw the derivation of equations in one dimension using the slope, area of the graph, and a little bit of maths here and there. So please make sure, once again I'm saying, these equations can only be used if during the entire journey the acceleration remains constant. The second part is these are only used if the entire motion is in a straight line, that is, it's a one-dimension motion. You can still apply these in circular motion if you have a good knowledge of simple harmonic motion. I hope you might have enjoyed the explanation. Thank you very much for watching the video. If you haven't subscribed my channel, please do that. Thanks a lot.